Hello, hello, hello. Alright folks, we're working with normal distribution. Again, this is the second video for this section. You've learned how to do what the goal says basically. You've learned how to calculate probabilities for random variables that are normally distributed already. But what we did specifically in the first video was we were working with the standard normal distribution. And in this video we're going to focus on the normal distribution that's not standard. By which I mean the mean is not going to be 0 and the standard deviation is not necessarily going to be 1. Alright, now in terms of how this works out, it's simple with your calculator. I'm going to do a couple extra things to help you understand what it is that you're figuring out, okay? And you'll see what I mean as we go. Alright, here you might remember the notation for normally distributed. It says that the random variable x is normally distributed with a mean of 75 and a standard deviation of 8. Remember, the first parameter there is the mean, and the second parameter is your standard deviation squared. So the variance would be 64, for instance. And what we're going to do is we're going to try to find the probability that that random variable x has a value between 64 and 75. Alright, now what we do on the calculator is very simple here, but in order for you to understand the answer, what I'm going to go ahead and do is draw a normal curve. And remember, with a normal curve, the highest frequency occurs at the mean. So I'm going to draw a line here that represents the mean, and for this problem, the mean is 75. And then remember, what I would always draw is what is one standard deviation above the mean, what is two standard deviations above the mean, what is three standard deviations above the mean, and the same thing for below the means. Now in a standard normal distribution, you would have 0 here, and you'd have 1, 2, 3. Alright? But here, the mean is 75, and one standard deviation is 8. So what I'd like you to get started thinking about is, what does it mean if it's one standard deviation above the mean, or what does it mean if it's two standard deviations below the mean, or that kind of thing. Well, if the standard deviation is 8, that means in order for a data value to be one standard deviation above the mean, it'd have to be 83. And then for two standard deviations, it'd have to be another 8, 91. And then three standard deviations above the mean would be 99, right? Now, those have z values that correspond with 1, 2, and 3. Okay, remember the z value tells you how many standard deviations away from the mean it is. We can do the same type of thing to figure out what one standard deviation and 2 and 3 standard deviations below the mean are. We just have to subtract 8 from 75. One standard deviation below the mean would be 67. Then subtract 8 again. 59 would be 2 standard deviations below the mean here. And then 51 would be 3 standard deviations below the mean. And the z-scores for those three values would correspond with -1, -2, and -3 consecutively. That's not really the thing I was meant to say, but hey, respectively, that's the word I'm looking for. Now this picture right here is going to help you interpret the answer to your question more than it is going to help you answer the question. Because the way we're going to answer the question is we're still going to use the normal CDF function on our calculator. And remember, the way that you use that is you say what is the lower boundary and the upper boundary for the value you're trying to find the probability of. Okay, we're saying that x has to be somewhere between 64 and 75, so we'll put 64, 75. And then remember, you also have to tell your calculator what the mean and standard deviation for your normal data set is. And in this case, that is 75 and 8. Now just use your calculator and it will tell you what percentage of the data values fit between those two numbers. Alright, and you can write your answer in decimal or percentage form. I'm going to write it as a percentage here. About 41.5% of the data values fall between 64 and 75 under this normal distribution. So, a 41.5% chance that a value would be between there for that random variable x. Alright, now we'll do the same basic thing to find out what's the probability that a random variable in this distribution would be less than 85. Alright, but remember, whenever you're just saying it's less than 85, your lower boundary needs to be negative infinity. And of course, you can't actually type in negative infinity on your calculator, so we're using -1 times 10 to the 99th power instead for our lower boundary. So about 89.4%. All right, I want to give you a couple more pictures just so I know you know how to interpret those answers, and then we'll move on and we'll try one more example. I'm going to draw two more normal curves. Now, if you recall, I told you that the probabilities associated with a normal curve represent the area under a particular section of the curve. So in part A, when we figured out that the probability that a data value would be between 64 and 75 is 41.5%, that means if I find the number 64 and 75, remember 75 was the mean right there, and 64, which was a little more than one standard deviation below the mean, around right there, we're saying that this area right here is about 0.415. Remember, the total area under the curve is 1, so that makes it 41.5%. And then for part B, whenever we're saying x is less than 85, well, 85 is slightly more than one standard deviation above the mean, correct? So that's kind of saying if you had 85 right there, and you want to know the probability that something was less, that's telling you that the area of everything to the left of that is 0.894. Or about 89.4% of the total area under the curve. Good. You need to be able to interpret your answers that way. All right. One word problem involving this, and then we'll move on. Here we're saying that the volume of water in bottles claiming to contain 500 milliliters is normally distributed with a mean of 503 milliliters and a standard deviation of 1.25 milliliters. Now, this is not true for every 500 milliliter bottle, but I'm just saying for the sake of this problem, let's pretend that a company claims its water bottles are containing 500 milliliters, but that's just what it states on the bottle. It can't fill the same bottle to exactly 500 milliliters every time, and so what's actually happening here, according to this problem, is that the mean volume of every bottle is 503 milliliters. They're trying to err on the side of giving you too much rather than too less. And the standard deviation is 1.25 milliliters. First thing we're going to do is we're going to find the probability that a bottle chosen at random contains less than the advertised value, contains less than 500 milliliters. All right, now I'm going to draw a picture so that we can interpret this, and then we'll use our calculators to actually figure out the answer. All right, we want to label the mean. The mean was about 503 milliliters. I'll just make that go all the way up there. And then one standard deviation is 1.25. So one standard deviation above would get you to 504.25, right? And then so on and so forth. If we're going down, we would be subtracting 1.25 at a time. So one standard deviation below would be 501.75, and so forth. Now, where would 500 fit on that? Well, it'd be a little less than two, or a little bit more than two standard deviations below the mean, because when z equals -2, you'd have 500.5. Okay, so we're talking about a little bit more, again, a little bit more than two standard deviations below the mean is where the advertised volume of these water bottles is. Now, we're trying to find basically this: the probability that the volume, if we call, say the random variable is v for volume, the probability that the volume is less than 500 is what we're finding, and you're going to use the normal CDF function to calculate that probability. All right, so here's what you're typing into your calculator. Well, we got a very small number there, 0.00820. About 0.820% of the water bottles are less than 500 milliliters. All right, so this company does a pretty good job of giving you at least 500 milliliters. There's about a 99.18% chance then that if you bought a water bottle from this company, it would actually contain at least the advertised volume. There you go. All right, so one more question based on this, and this is a curveball for you, really. Now we're going to say that 10 bottles are chosen at random that this company is selling. And we want to know what is the probability that no more than 2 of them contain less than 500 milliliters. Well, this is no longer really a normal distribution question. This is really a binomial distribution question. Can you see why? It's because now we're saying we have a certain number of bottles, and there's either they are filled up enough or they're not filled up enough, right? Either they don't contain less than 500 or they do contain less than 500. So there's two outcomes, fixed number of trials, and we just figured out what the probability of success is, and thus the probability of failure in the previous problem. All right. So let's translate this here. Let's just say random variable x is supposed to represent the outcome when a certain number of bottles out of 10 are found to have less than 500 milliliters, okay? It's binomially distributed. The number of trials is 10, and the probability that it will contain less than 500 milliliters is what we just found, 0.00820. All right, so there's our N and our P. And what we're trying to do then is we're trying to figure out the probability that x is no more than 2, right? So that x is less than or equal to 2. So that's going to be a cumulative binomial function that we're working with. We're going to use binomial CDF. And remember, the parameters for binomial CDF are that you put in the number of trials, you type in the probability of success, which in this case is that a bottle does not have more than 500 milliliters, or contains less than, and then you put in the number of, what is the number of successes that you want up to, and we want up to 2 successes here, so we'll put in a 2 right there. And that's going to give you your probability. And this was a very high probability. In fact, the 3 significant figures, it is 100%. Because it's 0.9999, so anyway, about 1.00. So it wasn't actually 100%, but it's darn near enough certain that no more than 2 bottles will contain less than 500 milliliters from this particular company. All right, great. So now you know how to work with normal probabilities, or probabilities for random variables that are normally distributed, even if they're not a standard normal distribution. Thanks for your attention. We'll learn more about normal distributions in later videos. Thanks.